Hello everyone, welcome to a introduction on buck converters on Tina. For this video we'll be going through making a buck converter that allows us to step down from a higher voltage DC source to a lower DC voltage. We'll also be looking at its transient response and looking how to find other buck converter examples on Tina. So let's get started. First, open up your Tina, then go into your basics. We'll need a voltage source. We'll also need a voltage generator for a PWM. We'll also need a resistor. For rotating components, you can hold Control and R to rotate your component. A capacitor, an inductor. From there, we can go into semiconductors to get our diode. And we will also need a MOSFET. We'll be using an NMOS. And from there, we'll need to wire it up. We're going to do the same configuration that we have here on the Word file. We're just cleaning up here. So there are 3 ways to prompt the wire. One, you can just hover over a node, click. No need to drag. It's a click, stop, click, end. Or you can hit your space button as a shortcut. There is also a button here for wire. You can also click that to prompt the wire. Again, we are making a buck converter that will step down from 10 volts to 5 volts with an expected current output of 0.5 amps. And it will be at 500k hertz. Let's make sure this is connected. Seems to be a wire there. Go. This is considered an asynchronous buck converter because it only has one MOSFET. Asynchronous typically has 2 MOSFETs, which is controlled by a gate driver. We'll be talking more about that in the next couple of videos. For the PWM, we want to make sure we connect back up here and not towards ground. Speaking of ground, we do need one. Let's not forget that. And we're just cleaning up a bit here. For the sizing components, we'll be talking about that in the next video as well. This is at 5 micro, 1 micro, 10 volts input. Just clean up here. Now we'll be adjusting the PWM to be 500k hertz. We just double click the PWM, click on unit step, click these 3 dotted button, and we'll go into the signal editor. We want to select the general. We have an amplitude of just 5. Oops. Here's my little cheat sheet. We'll be going through how we got these values in the next video as well. Micro. This is when the MOSFET's on and off. Great. Now we will need to put meters. There are two ways to put on a voltmeter. I like to use a voltage pin. You can simply just place it here on where you want to find the voltage. We'll call this V out. You can also put one of these guys, I believe it's labeled as a voltmeter. You'll need it to be in parallel with a resistor. We should call this just V out 2. Just to show you that it's the same method. In order to run the transient, we'll go through analysis, and we can hit transient right here. You want to calculate at operating point and draw the excitation. 1 millisecond is fine for this example. And it looks kind of messy now, but if you go into view and separate curves, you should be able to see here, same graph as expected. We need to zoom in, simply click zoom, and go over, hold and drag over the area you want to analyze. Right here is our PWM. Simply click for the cursor, click on the waveform, that's roughly 4.4 volts. These are real components, so it's not very ideal. We're expecting around 5 volts. Lastly, we want to see the current for V out in the meters tab, and just hover over this one. I believe this is called a current arrow. We want it in parallel with the resistor, so we'll need to delete the wire. Insert this guy over, make sure it's connected. We'll call this I out. We're expecting 0.5 amps. Again, transient, and view and separate curves. You want to zoom in. And it's roughly 0.44. If you want to see an example of a synchronous buck converter, you can go into File, Open Examples. Here in Examples, look for a folder called SMPS, SIMPS. Just double click that, go into General, and here we have a synchronous buck converter. And as you can see for this one, there are 2 MOSFETs. And here is the buck controller, the gate driver, which controls the high drive and the low drive. And that's it for this video.